Hi boys and girls, this is the video for Wednesday and Thursday on math properties. And in your packet, for Wednesday, it'll focus on most of the properties, and then Thursday will be only for distributive property. So when you get to your Thursday work, just go ahead and rewatch parts of the video if you need clarification on certain things, and you should do great. So I'm going to start by going through each of the properties and kind of what makes it fall into that category of that property. So for the first one, it's the zero property of multiplication. And what it says is that the product of any number and zero is zero. So we know that product is just another word for basically meaning the answer. So basically what they're saying is that any number times zero equals zero. So this, in the example, could be 8 times 0 equals 0. It could be 52 times 0 equals 0. Or it could be 5 million times 0 equals 0. It will always equal 0 if you're multiplying a number by 0. And the reasoning for that is because you have your number here, and then you're multiplying it by 0 times. So since it's being multiplied by 0 times, it's going to equal 0 because there's nothing. So that is the zero property of multiplication. So anytime something is multiplied by 0, the product is 0. That one's a pretty easy one, and same with the identity property of multiplication. And what they're saying is that the product of any number and 1 is that number. So again, product means the answer. So they're saying that if you multiply any number and 1, the product is that number. So they're saying that the product would be this number here that's not 1. So 4 times 1 equals 4. And the reasoning why for this one it stays the same is because you're taking that number and you're multiplying it by 1. So when you multiply something by 1, it's still just itself because it's there only one time. So it could be 7,432 times 1. And the answer will always still be just that first number or the number that's not 1. So the answer would be 7,432. It could be 10 million and it times 1, and the answer would still be 10 million. So that is the identity property. Both of those first two properties are pretty simple. So anytime you see a number either being multiplied by 1 or by 0, you should kind of have a flag go up, a little red flag that's telling you that to not even do the work. You don't have to show your work. You don't have to write anything out because those are the ones that you should definitely just know off the top of your head if you know that property. The next one is the commutative property of multiplication. So this is about the order. So the order in which 2 or more numbers are multiplied does not change the product. So what they show here is the number 4 times 7, which we know is 28, is equal to 7 times 4. So 7 times 4 we also know is 28. So 28 is equal to 28. So no matter how you set it up, it doesn't matter. You can put the order of the two numbers does not matter. So if we have 3 times 2, that equals 6. And if we do 2 times 3, that still equals 6. So with multiplication, you can flip-flop them, and it does not matter because it's still going to have the same answer. So that's called the commutative property, where you're basically just changing the order of the 2 or more, which is really important. 2 or more. So it could be 3 numbers, 4 numbers, 5 numbers. It doesn't matter. The answer will still be the same. So that's really important to notice, especially if on a worksheet you have 2 math problems. Say you have 100 times 2 and then 2 times 100. If you do the math for one of them and then you notice that it's the same numbers in another problem, then you already know the answer. So that one's really important to know as well. So that's the commutative property. All right, the next one is the associative property. So this is when 3 or more numbers are multiplied, the product is always the same regardless of their grouping. So the thing to know and to always have a red flag up about with this property and with other problems is that parentheses go first. So no matter what, you always solve your parentheses first. And what the associative property is saying is that when there's three or more numbers that are being multiplied, it doesn't matter how you group them. So it doesn't matter really where those parentheses are. Because as we can see here, we have the three numbers that are being multiplied, 3, 7, and 9. And it's the same over here, 3, 7, and 9. But you can see the difference is that in this one, we have 7 and 9 that are grouped together with parentheses, whereas over here we have 3 and 7 that are grouped together. So the way that you would solve this problem, whether it's this side or this side, is that you would start with your parentheses. You always start with your parentheses, always. I'll put a star here with a P for parentheses. Always start with parentheses. So you would do 7 times 9 first, and then you would multiply that number by 3 to get your answer. And it would be the same answer if you did 3 times 7, multiplied and got your answer, and then multiplied that number by 9. So the answers would be the same. It does not matter how you group them. So that's the important part with associative property. And just know that when they say grouping, that's basically them saying how they group them together with their parentheses. So you could see that you could either group 3 and 7 or 7 and 9, just like they show you in both of these examples. All right, and our last and final property is the distributive property. So this is the one that you will really focus on all day Thursday. And this is basically just saying that the sum of two numbers times a third number is equal to the sum of each addend times the third number. So that's kind of a whole little jumble of words. But basically what they're saying is that when you add up these two numbers, so this could also be written as 3 times 16, right? Because 7 plus 9 is 16. But what they're saying is that you can break this apart where it's 7 plus 9, or say it was 16. You can choose one of these numbers to break apart, just like they did here. So they broke apart the 7 and the 9, and they brought the 7 here, brought the 9 here, and they did 3 times 7 plus 3 times 9. And then you would solve for each of these. You would do 3 times 7 and then 3 times 9, and then you add that together. So the reason why I wrote 3 times 16 up here is because sometimes you would see it up here, or not up here, but you would see it written as just a whole number. So maybe you would have 2 times 8. And say 8 just was too large of a number for you to multiply by 2. I know that you can all probably do 8 times 2. But so say you want to break it apart, you could do 2 times, and then you get to pick. This is where you have the choice of how you want to break apart 8. So you could do 4 and 4, 6 and 2, 7 and 1, but I'm going to do 4 and 4. And the important thing to notice, or to note, is that you can only choose one number to break apart. So you're not as often going to see it laid out like this as you are going to see it laid out just as a normal multiplication problem, such as 10 times 5. You would see it like that, and then you'd choose to break apart the 10, or the larger number, to probably make it easier to multiply. But let me continue on with the problem. So then you would solve for this one. 2 times 4 is 8. 2 times 4 is 8. That kind of looks like an addition sign. And then you add the two together. 8 plus 8 equals 16. Therefore, 2 times 8 equals 16. So you can see how you can choose to break apart that number. But like I said, the thing to note is that you can only choose one number to break apart. So say you are multiplying 9 times 9. You can only choose one of those 9s to break apart. So say I choose the second 9. Then I would do 9 times, we'll break it apart into 5 and 4. So 9 times 5 plus 9 times 4. And then you would solve. And basically what the distributive property is doing is it's just making a multiplication problem easier for you by allowing you to break one of those numbers into a smaller number, because it's much easier to multiply 9 times 5 and then 9 times 4 than it is to do 9 times 9, because it's a larger number. Or say 10 times 5, you could break apart that 5, or that 10, into a 5 and a 5. So then you could do 5 times 5 plus 5 times 5. So that looks a little sloppy on my paper, but I'll show you some examples which might help clarify that a little better. But just with distributive property, the one thing to really remember is that you only get to choose one of those numbers to break apart, and then you are adding it. When you add you do 3 times 7 and you multiply it, but then you add it with the 3 times 9 for the other number. So that is distributive property. I'm going to do a quick little review on all of the properties where it's this little matching thing. And so over here it has the properties listed, and then over here it has examples. So rather than using the words and finding which one matches, I'm actually going to start with the problem and see if I can identify which property it is. So I see 6 times 0 equals 0. So the first thing that I notice is that I have a red flag in my brain that's telling me I see a 0. So I know that anything times 0 equals 0, and it's even easier to match up with because the name of the property is called 0 property. So I'm going to match this one up here with 0 property. So I'm going to move on to the next one. 5 times 3 is equal to 3 times 5. So I don't see any zeros. I don't see anything times 1. So I know that it's either commutative, associative, or distributive. And what I'm seeing is just that the order is switched. So 5 times 3 equals 3 times 5. They basically are just flip-flopping those two numbers. So this one is actually commutative property. And you're not going to have to memorize them like this, but I'll bring you back to the commutative property slip. So this just says the order in which 2 or more numbers are multiplied does not change the product. So the commutative property is all about the order. So I match that one up with the commutative property. All right, so for the next one, I have 6 times, and then in parentheses, 2 plus 7 equals 6 times 2 plus 6 times 7. And it's actually harder when you see it written out like this. I'll actually write on the back of the slip and show you kind of how you might also see it written out. So it would really be 6 times 9. And then they're saying 6 times 7 plus 2. So they split up that 9 into 7 plus 2. Then the next layer, it's kind of easier to look at it as layers, because when you see it, or when you choose to do distributive property, you will see it kind of in just a normal problem like this. So then the next layer, when you break it down, would be 6 times 2, or 6 times 7, plus 6 times 7. And then you would then solve for each one and then get your answer. But that's kind of how the layers work. So just so you can kind of see why this first one is in parentheses. And so I gave you the answer to that one already. That one is distributive property, because you are choosing to split up a number and multiply it by that other number and then add it together to make it easier. So then our next one, I have a red flag because I see that there's a 1. 1 times 12 equals 12. So that is the identity property, which is anything times 1 equals that number itself. And then the last one is obviously associative property. We'll pull out the little slip for that one. So this one is that when 3 or more numbers are multiplied, the product is always the same regardless of their grouping. So you can see that this one is very similar to the example where they have a number and then the other two numbers in parentheses, and then they basically just switch it and they just moved the parentheses pretty much over and then multiplied. So they're just saying that regardless of the grouping, the product is always going to be the same. I'll actually keep this out here for another minute. So this is kind of another example of all those properties and how they would look. And so I'll just do a few more examples on each of these pages to show how I kind of walk through each problem for each different property. I'll only do a few, and then you guys have your work problems to do and then your EdSpeak quizzes throughout the week. So just check in with me if you're having any struggles or if you're not understanding. Please do not feel like you need to memorize them, because you don't. It's more important that you just know how to work through them when you see it rather than necessarily memorizing the property. So for the first problem, 7 times 0, I see the 0, and I know that anything times 0 is 0. 0 times 5. So again, anything times 0 is 0. Even if we hop all the way over here, 9 times 0. Anything times 0 is 0. So that's the 0 property. I could do this whole page and they'd all be 0. Even this one, 0 times 0 would still be a 0. So 0 property, you guys should have that one down so well because that one's pretty easy. Identity property, this one is the next one that's pretty easy. So remember, it's just anything times 1 is the product would be that first number, or it could be in the second spot like here, but basically it's just the number that's not 1. So 4 times 1. So I know that it would be 4. 3 times 1 would be 3. 5 times 1 would be 5. 9 times 1 would be 9. We can kind of skip around. 10 times 1 is 10. 1 times 7 is 7. 1 times 1 is 1. So that's the only case where it would actually be 1, because 1 times 1 is 1. So that's the identity property. And the next one is the commutative property. So let's do a few of these examples. So 4 times 3 is 12. 3 times 4 is also 12. So you can kind of see, I'll draw little arrows to show how they just flip-flopped them, because they took that 4 and they just made it the second number here, and they took the second number up here and made it the first number. But you can see that they both still equal 12. The next one, 6 times 2 is also 12, and 2 times 6 is also 12. We'll skip around more. 9 times 6 is 54. 6 times 9 is 54. 9 times 6, 54. And we've taught you guys that 9 trick. I'll show you it again. That anything times 9, so say you do 1 times 9, you put down that first finger, and then you count how many fingers you have on this side of the finger that's down. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1 times 9 is 9. Then if you want to do 2 times 9, you put down your second finger, and then you go on this side of the finger, so there's a 1, so that's your tens place. And then over here, 1, 2, 3, 4, 5, 6, 7, 8. There's 8, so if you have a 1 and an 8, that's 18. So 2 times 9 is 18. 3 times 9, you put down that third finger, and then you would add up these two, so that's 2, so that's your tens place, so that's 20. 1, 2, 3, 4, 5, 6, 7, 27. So you know 9 times 3 is 27. And that works for all your fingers all the way up. Obviously you only have 10 fingers. But that's a nice little trick that I still use, even though I was taught it 10 years ago. So back to the commutative property. 5 times 1 is 5. 1 times 5 is still 5. So you can just see this sheet basically just shows how no matter how you flip them, they're still going to equal the same thing. That is commutative property. On to associative property. So this one's all about the grouping or the parentheses. So that should kind of ring a bell to you to know to always look for the parentheses first. But really in this case scenario, it's not super important because the grouping can be changed. But let's start with those parentheses. So 3 times 2 is 6. And then we do 6 times 4, which is 24. All right, so then now we can see that the parentheses have shifted and they go around the 4 and the 3 now. 4 times 3 is 12 times 2, 24. So even though they may look very different, they still have the same answer. Let's do a few more. 1 times 2 is 2 times 3 equals 6. 2 times 3 equals 6 times 1, that's the identity property, equals 6. And then 8 times 1 is 8. 8 times 5 is 40. 8 times 5, or 5 times 8 is 40. Times 1, that's also the identity property, so that's still 40. So you can kind of see the identity property was built right there into the associative property, which you might see, because here it could have a 0, and that would be the 0 property. So you just always want to remember those things no matter what section you're working on. So even if you're working on the distributive property portion of your page, there might still be some identity property mixed in. So always just be aware of all of that. So for this one, remember, talks about kind of splitting those two numbers up, or it would actually be that one number. And you multiply the two different groups and then you add them together. So I'm always going to write just kind of how you would see it, maybe if this wasn't already split for you, because they already decided that they wanted you to split 5 up into 3 and 2. So this you would see sometimes as 4 times 5. And then they made the decision here for you to split it into 3